All right, so number 26, they asked us to graph 3 equations. To sketch the graphs of y equals x squared, y equals 2x squared, y equals 1/2 x squared. When they say to make a graph and they give you an equation, your fallback plan is to do the same thing we did way back in chapter 1. You make a table first. You use your table to graph some points and you connect those points to make a curve. Sometimes it ends up being a straight line. These ones are going to be curves. And then we're going to compare and contrast the 3 graphs. So if I got an equation, I'm trying to make a table, all you're doing is taking the x values from your table, plugging them into the equation, and writing down what you get. So what do I get when I put -2 into x squared? What do you get when you square -2? You get +4. -2 times -2 is +4. So this would be 4. If I put -1 in here, I'm going to square -1. -1 times -1 is +1. If I put 0 in here, 0 times 0 would be 0. If I put 1 in there, 1 times 1 is 1. If I put 2 in there, 2 times 2 is 4. So you're using the equation and the x values to come up with your y values. And then we can graph those points. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. And that shape looks kind of familiar to me. Does anybody remember that P word? Thank you. This is a parabola. We did lots of descriptions of parabolas. We talked about where's the vertex, where are the x-intercepts, where are the y-intercepts, is there symmetry, where's the line of symmetry, all that stuff back in chapter 1. You'll still be responsible for knowing all that stuff because we've been practicing it in our homework. You will see it all again here in, how many weeks do we have left? Is it 7? I think it's like 6. Yeah, we've got 17 gold days and 17 blue days left. So, and the last of those days is going to be a final exam you guys are going to be taking. All right, let's talk about the next one now. This one, I could go through that same process again, or I could be sneaky about this and save myself some work. What's the difference between these 2 equations? This one, it has a 2 and it's multiplying by x squared, right? So wouldn't I just be able to take all of my numbers from x squared right here and just multiply them all by 2? Wouldn't that be an easier way than going back and plugging this into each of them? That's what I'm going to do. This is x squared, right? This is 2 times x squared. So I'll just take all these x squared values and multiply them times 2. 4 times 2 is 8. 1 times 2 is 2. 0 times 2 is 0. 1 times 2 is 2. 4 times 2 is 8. So we end up getting those points, and then we got to plot those as well. It's too high. And we get, oh my goodness, look, it's another parabola. This one's taller though. And then I can do the same thing for this one, except this time instead of multiplying by 2, I'm multiplying by 1/2. So I'll go back to my original x squared numbers and I'll just multiply them each by 1/2. 4 times 1/2 is 2. 1 times 1/2 is 1/2. That's 0.5. 0 times 1/2 is 0. 1 times 1/2 is 0.5. And then graph those up. See, -2, 2. This is 1/2, 0, 1/2, and 2. And that gives me yet another parabola. Okay. So when you run into a problem that asks you to sketch a graph and they give you an equation, you're going to have to make a table and then sketch your graph from the table. And the points that I will usually start with for my table, I'll put 0 in the middle and then go to from -2 on one end and 2 on the other end. So they said compare and contrast. I'd say, what do they have in common? They're all parabolas. They all open upwards, don't they? Y-intercept, same for all of them. Y-intercept 0 for all of them. X-intercept, same for all of them. 0. Vertex is the same for all of them. If they wanted to know what's different, I'd say it kind of looks like the one that was multiplied by 2 got stretched out vertically. It's twice as tall as the original one. And it kind of looks like the one that got multiplied by half got squished down, got compressed. All right, we good on that? Anybody need a minute to finish up their tables or graph for 26? So everybody should have 26 done now. I can't hear anything you're saying. Okay, I'm done stamping for right now, so I'll have to take care of that later. Let's look at 27. All right, so this one described two people that are saving money. And it's good that this is in here because this could have a lot to do with what we're doing today. Today's all about money, guys. Today is the most important day of Algebra 1. I'm not joking. So this is about two people, Morgan and Kendall, and they are both they both have a bank account. And they gave some information about their money spendage, savings, and current values. And then we're supposed to write equations and then solve the system of equations. So since this is a situation where we have some starting value and we're either adding or subtracting the same amount each time, we're going to be writing an equation that's going to look like this. This is that y equals mx plus b. So we need to know the start and the change for each of them. So as I start reading through here, I need you to make note of the start and the change. So Morgan started the year with $615 in the bank and is saving $25 per week. So is Morgan's amount of money increasing or decreasing if she's saving $25 per week? It's increasing. So this would be plus 25. She's adding $25 into her savings each week. Kendall started with $975 and is spending $15 per week. If Kendall's spending $15, is that positive or negative? It's negative. It's going to be decreasing. I flipped those around, didn't I? I just realized I put those in the wrong spots. Sorry. Didn't I? I had start here. This isn't the start, is it? These are the starts. I didn't read my thing very well. So this is a change and this is the start. My apologies. So then we need to write an equation. Change comes first, start at the end. So y equals 25x plus 615 and y equals negative 15x plus 975. So they want to know when both people are going to have the same amount of money at the same amount of time. Did they tell us to do let statements? They didn't. So you're going to see a problem in today's homework, which you're going to have a good chunk of time to start on, where it's going to say do a let statement for your equations. What I do in place of a let statement is I draw some arrows and say what's what. Like y is representing money here. We're starting with this amount of money. We're changing by this amount of money. So y is in dollars. And x is what? Is it number of days, number of weeks, number of months? I got to look back at the problem. It says she's saving $25 per week. So x must be the number of weeks. So we're going to figure out at some point they're going to have the same amount of money. How many weeks in is that and how much money do they have? And to do this, we'll solve a system. Which of our four methods would you use to solve this system? Graphing, equal values, substitution, or elimination? That looks definitely like an equal values equation because they're both y equals, right? So let's write that equation. 25x plus 615 equals negative 15x plus 975. And then we just need to go through our steps to solve that. You all have been practicing that quite a bit for the past 6 weeks or so. I'm going to leave those steps to you. If you need me to walk you through how to solve that in a little bit, we'll have plenty of time later on. Okay. What other questions do you have from? Actually, let me show you answers to homework first, and then we'll see if we have any more questions. All right. So here's 24 part B. They're asking us to fill in this table And they were so nice to tell us that it was going to be in the format y equals something times something to the x power. I got a big question for you. If the equation looks like this, does this look more like a linear equation or an exponential equation? Linear or exponential? What do you think? So if I were to graph this, is it going to make a straight line or is it going to be curved, kind of curving? What about this one up here? If you were to graph y equals mx plus b, is that going to give you a straight line or is it going to be curved? This is linear. Linear means it's going to be a straight line. This style of equation will be linear, which means this is exponential. Okay. So this is going to be our exponential format. We've taken some notes on exponentials. Just to remind you of our notes from Thursday, the general form of an exponential function. Doesn't that look a lot like what they tell us to write here? Yep. And on Thursday, we took some really detailed notes about how we could, what is A and what is B? B is a multiplier, A is the y-intercept or the starting value of the y when x is equal to 0. So they didn't actually ask us to write an equation, did they? But they asked us to figure out what the multiplier was. Oh no, we are going to write the equation. Okay. So what we need to know is a starting value here. And from the table, what's my starting value? 5. Starting value always happens when x is 0, so we'll put a 5 in there. This is the tricky part on this, is we need a multiplier. I need to know what am I multiplying by each step as I go forward. And I don't have 2 back-to-back steps, so I can't do that division trick. So I'm going to teach you how to do this a little bit later on, but for right now, we're going to have to rely on guess and check. So I need a number that I can multiply 5 by, but I've got to multiply it 2 times because I'd have 2 steps here, right? So someone give me a guess. I'm looking for a number that I can multiply 5 by 2 times to come up with 180. 5 times 6 times 6 is 180. That was a great guess. Fantastic. All right, we nailed it on the first try. When I did this, I had to try a couple. All right, so times 6 and times 6 gets me to 180. So what would this one be? 5 times 6 is 30. And let's just check, is 30 times 6 180? Sure is. And if I wanted to keep going forward, I would do 180 times 6, which is 1080. So that's our next one. And then times another 6, which is 6480. And we just need one more number for our equation here. What's it going to be? 6. That's our multiplier. Thank you for asking about that one. That's going to have a lot to do with what we're doing today. You guys are asking great questions to lead us into our new stuff for today. Any other questions? All right, I appreciate it, folks. We're going to move into our notes now. I'm going to put this in my notebook, and then you might decide later on. Yeah. Oh, one more? Okay, we got time for one more. The last one, part E. Oh, yeah. Let's talk about this real quick. Well, it's not, though. I think, so this is 28 part E. And for me, this was the trickiest one because it didn't give us numbers. So it's a sequence. It goes up through F. And the sequence is x plus 1, x plus 2, x plus 3, comma, dot, dot, dot. And the question is it arithmetic or geometric? You're guessing arithmetic? That's a good, it's a 50-50 guess, right? So you want to tell me why you're leaning that way? Yeah, what happens when I do x and I add 1 onto it, I get x plus 1, right? So I am doing plus 1 here. If I had x plus 1 and I did another plus 1 on top of it, this one and this one would combine together and we'd have x plus 2, agreed? And each time as I add another 1 onto it, that number is going to increase because 2 plus 1, they're like terms, they're going to increase to give you 3. So it is arithmetic because we're adding 1 each time. It's just weird because we don't have a concrete number. Did they ask us to write an equation for this? Oh, okay. Yeah, we could do it. We need a 0th term, don't we? This is the first time. So if I want to go backwards, you got it. I got to go, the opposite of +1 is -1. So if I do x and -1, I'm going to get x -1. So there's my 0th term. And we want to write an equation for it. Now this is a sequence, so we're going to write t of n instead of y. But it looks a lot like that linear equation that we just wrote. Something n plus or minus something. What's this going to be? Is this going to be, this is how much we're changing each time. So it's just 1. This is how we're adding 1 each time, right? This is the change. And this is our starting value, or our 0th term, which you just figured out was x -1. So my equation would be t of n equals 1n plus x -1. And so it's a weird one. And that's all we can do with it. Are we going to see more of them like this? This is not like a test level question. This is like, let's stretch our brains a little bit. Now, when you get into algebra 2, you'll be dealing with some more abstract type of problems like this. But no, this one is a brain stretcher. All right, we got to move on now, folks, because we got some important stuff to do today. I think I warned you about this before. By the way, while we're switching gears here, if you don't have a book, go ahead and make sure you got one at your table. It looks like most people do. I think I warned you about this before. I said that we were going to get into some stuff in this unit